Hello and welcome back to another video of breaking things until they work, or at least figuring them out. I'm Justin Garrison. I'm going to tell you all about Talos Linux and system extensions today. System extensions are the way you extend Talos Linux, and there's a couple different ways they work, so I want to walk through everything from using system extensions all the way to creating system extensions. This video might be a little bit long because there's a few different use cases and ways you make them, but you can use the chapters down below to skip ahead if there's only a specific part that you're interested in. But the first thing we need to do is just install Talos Linux. And also I'm going to make some assumptions here that you know what Talos is. You're not looking for necessarily the full getting started. We're just going to dive right into system extensions and show you what they do. So the first thing I want to do is head over here to factory.talos.dev, and this is where you can build a customized version of Talos Linux for whatever you're trying to do, including system extensions. And in this case, I'm going to say I want a bare metal machine because that's what I'm going to use to show off how this works. I'm going to use whatever version of Talos I want. I'll start with 110. This is going to be an AMD 64 machine, not ARM 64. And here's my system extensions. These are all the official system extensions, the extensions that are built by Sidereal Labs for a release of Talos. All of these extensions are built for Talos Linux 1.10.2. So if I have like an older version for another version of Talos, it's not showing up here. This is only the ones built for this version of Talos Linux. And you just select them. If you want something in here, all these are doing is layering a container on top of the Talos file system. That's it. Every system extension is just a container. Surprise, I'm sorry, it's not magical. It's just a container. We'll show you how to build it in a little bit here. But let's say I want to do, the box I'm going to install it on is an Intel CPU. So I'm going to search for and install all of the Intel U code, the i9-15 and the ICE firmware. Let's just grab those. And this is going to be for my installation media, my boot media, which gives me here, I have this extensions, and now I can get my ISO. Here we go. Two things you should note based on this is one, this schematic ID is for this configuration. So if I want to change versions of Talos, I could use the same schematic with a different version and I get this same configuration. So let's say the U code's not available in another version of Talos. This schematic wouldn't work for that version because that extension's missing. You can either change that by like actually changing it in the URL here. If I wanted to say 10.1, I get the same thing with same schematic with a different ISO for 10.1. Let's download that installation media and we are going to put it on a USB drive. All right, so I copied this metal AMD 64 on here. I'm going to name it something a little more meaningful to me. Talos 110, this was 2, and I'm going to say Intel. And we will just rename it. And now I just need to take out that USB drive and boot a machine from it. Okay, so I have a KVM here that's plugged into the machine that's booting off this USB just to show you what's on the screen while it's booting. We're gonna go ahead and boot into that Intel ISO that I just grabbed. And we will boot up the system. This is going to start Talos in maintenance mode like any other standard Talos Linux install. You don't actually have to do it with the extensions installed. I'm just showing you this process because maybe while you're booting Talos on a machine, you don't have network drivers. So your boot media does need the extensions available. And when we do our install, we're going to actually permanently write the extensions to disk. So let's go back here and generate a Talos config, which is all just standard how we would normally generate this. Let's make that bigger for you. Gen config. I call this machine Z, and then we'll put our endpoints, generate the whole thing, and now we can apply this directly to that machine. Oh, you know what I forgot to do? I forgot to say my install disk is dev and what VME 0.m1. There we go. Now let's get the right thing going. Otherwise it tries to install to SDA, which I don't have on this machine. So apply insecure node, and then my file control plane. And we just did an install of Talos Linux. I'm sorry to disappoint you if it should be more involved, but that's the entire thing. It's going through the install now. But I want to show you that actually this install, even though I booted from media that had the system extensions, this install doesn't have my system extensions. They're not actually there. I didn't tell it what image to use for the installation, so it used the default. If I look at my control plane, you'll see here I have this install section and which image to use. It's using the generic upstream installer. That doesn't have any system extensions installed on it. So if I also export my Talos config, which is in this directory, and now let's go ahead and add my node just so I don't have to type it every time. Oops, nod's not a thing, node. And then let's do node for endpoint. And that just it runs the same command replacing node with endpoint. So now I can get extensions, get extensions, and I have none. I have no system extensions installed on this machine because, again, I use the vanilla installation media. And so I used the extensions at boot time, but I did not replace the image in the YAML file to say, hey, install with this system extension. The way you would do that is going back into Image Factory. We can see we actually have the initial installation. I can replace that image in the config file before my install. I also could do the same thing for the upgrade. So I can now actually perform an upgrade on that node with this image. So I can just say Talos control upgrade, I is for image, and the endpoint, the image that I'm going to use, the container image, I say, hey, use this installation media for your install, and that has the system extensions. We can see here that the cluster finished creating, so now let's go ahead and do that upgrade command so that it's not blocking. And in this case, I'm going to use that image from the factory with the for still, because it still is a single node cluster, and we're going to go ahead and do that install. So we can see validating here, it's going to go through this upgrade process, and now it's going to start shutting things down, and it's going to pull that installer image. Once this reboots, we'll be able to see that I have the system extensions installed because, again, I'm using that image. And it looks like the command line shows me that it checked all health checks, so it's ready to go. And if I do my get extensions command, I can see I have those extensions that I was looking for. The Intel ones that I added, this schematic here, which again comes from the image factory. And so I have what I needed from this node. I can also, none of these installed any like services. These are just files on the disk for drivers for the machine. So in that case, we don't need anything else. I'll show you services here in a bit. The same sort of process applies when you're using Omni. And in this case, I connected one machine into my Omni instance, and now I can go create a cluster with it. And in this case, I can go down here to my machines. I'm blocking that, aren't I? Let's go ahead and let's move me up out of the way so you can kind of see what this looks like down here. In this case, I think I booted this from 1.9 installation media, so I have to select a 1.9 cluster. I get my install disk, and then I can select which extensions I want. So in this case, I did boot that machine from AMD extension, so I already had that one on here. I could also add the AMD GPU for doing an install. I can save that and do my installation. And in this case, Omni is going to know to select the right installation media and add the extensions for me as I'm going through that process of doing the install. So I can go back on this machine. I can look at my extensions here on the last tab, and I can see that one was already installed because I booted with that, and one more is being installed because the system's fully being installed. Same thing with, I can update my extensions at any time here. I can just say, I want a new extension installed, whatever it is that you're looking for on a machine, you can add those directly from the UI without, it does the whole reboot flow. It's the same thing. It just does it in a nicer way. Okay, so that's the basics of using system extensions. And again, those are all system extensions that Sidero Labs, we provide or we build. They're not all necessarily ones that we are supporting. And some of them are community contributed, and we build them and make sure that they work with our tests. But it's not like we don't have expertise in Tailscale. It's one of the system extensions that is an example. It works, it's available, people wanted it, we build it because it is a popular thing to kind of build and put in there. But let's look at what it takes to create your own system extensions, right? Let's say you want to add some files to your Talos install. Instead of building Talos from scratch and trying to do it that way, system extensions are a way to be able to maintain that and build and extend Talos on the fly, like I just showed you through upgrades and whatnot. So there's really only one file that has to exist in a system extension, and that's a manifest file. So all you need to do is write a manifest file, put it in a container, and you have a system extension. Like it's as easy as that, but it's not really useful if that's all it is. So in this case, let's build a system extension with the manifest file to show Talos how to actually use it, and then one file on the root of the file system. And so to do that, we will, let me take this example here, copy and paste it in. So here's an example of a file that I'm going to write. This is my manifest file, and this is going to have a version that I need and some metadata, which is the name, the version of the system extension, and a description author. Write that file in, and then let's also create a Docker file that is going to build a system extension with that manifest. Here's my Docker file, which is just going to be from scratch. It's going to add my manifest, and then it's going to add a hello file to the root fs directory of hello. And I'm going to echo in I was here into hello. And now we just need to build it. So I'm going to randomly generate extension image ID just for the fun of it. And let's go ahead and build this with Docker using that image ID. I'm going to use a service here called ttl.sh. I found out about it recently, and it's just a temporary Docker registry. So it just lets me have images that exist for some amount of time. And in this case, the 1H means it's going to exist for 1 hour. This image is going to be there for 1 hour and then disappear from the internet, or at least theoretically. I wouldn't trust it with anything to securely delete my data, but in this case, I have nothing secret or secure in this. So there we go. We built a container image with two files in it, a manifest file and a hello file. We built the container image, and then we pushed it to this remote registry. Now let's go ahead and build our Talos installer image using that system extension. For that, we're going to use a tool called Imager, and Imager will do a bunch of stuff for us. We also run Imager as a Docker container. So right here, you can see I have this Docker run, which is just mounting the out directory from my local directory, because it's going to spit out a image file for me. And then this is the container I'm running, and I'm telling it, hey, I want this system extension with the image name of what I just used. So it's going to actually compile those together for me. And it's going to build out an installer. There we go. Now let's check. We should have an installer AMD64 tar in my out directory. There it is. This is an exported container, like I don't want to say physical manifestation of a container image, but this is my installer image that has that system extension as part of the file system. So now I need to take this installer image and turn it into a way to install Talos with it. And the easiest way to do that would be to import this into Docker and then push it to a registry. I don't even need to do that. I'm going to generate another random installer ID. So I have this installer image. And now with that exported tarball, I'm going to use the crane command, which is just going to read the tarball and then push it to a registry. So you could do the manual Docker load, Docker tag, Docker push. Crane just does it all in one step, so it's really nice. And now I actually have this image that's available on that remote repository has my extension built into it. So we can upgrade my Talos install with that image already. There we go. We push that new installer image, this blob, which exists right here. That's the image that we did. So just for fun, let's go ahead and Talos control ls just to see what's on the root directory of this system. Nothing that says hello there. And now let's do an upgrade with my image that I just created that has that system extension. It's my installer. And we got to do a force again because, again, this is a single node cluster. Do that force. And over here on this other system, we can see we get the same Talos validating of my installer. And it's going through that upgrade process just like before. Just like with an official Talos install, we just created a new installer image that it's going to say it's going to pull down. Okay, everything finished there. So let's go ahead and get our extensions. Get extensions. And you'll see here, I only have one now. I had 3 before. I did not include the other ones in this base file system, so they were removed. It's not like it always adds them. I built a brand new image with this hello extension, and that's the only extension that's available now. I don't have a schematic for upgrades because it's not coming through the factory, all that stuff. It's just a raw system extension on disk. And I also could ls the root of the directory, and I see I have this hello file now, and I can also read that hello file, and I was here. So that was the whole process for creating a system extension from scratch on a custom Talos build. So if you need a custom files on disk, that is how you can do it. But there's something else we need too, where sometimes we don't just want files. Sometimes we want something else on the system. We want a service that runs. We want configuration for that service. So let's look at that real fast and show you what the process looks like to install a system extension that has a service running and also configure that service. If I go back and look at the image factory, we do have a bunch of extensions that have services in them. Tailscale, again, is just one example of a service that runs because it does run a daemon that is running all the time, and it also needs configuration. So the steps I'm going to show you on how to create your own system extension with a service will also apply to system extensions that already exist that have services running, at least for configuration and checking them. All right, so to get started with an extension that has a service running, let's go ahead and add a couple files to our extension. And I created this very simple Go binary that's going to run and just echo some text. And in this case, it's going to echo the text hello world, unless it gets an environment variable for echo text, and then it's going to change the text outputs. That's all it does. It just runs echoing text output, and it'll be fine. It's just going to execute, I want a service that does this for whatever reason. You can build these yourselves. You can do them with other daemons that exist if you have binaries for them, whatever the case may be. I'm just showing as basic as possible. So let's change my manifest to be echo service and echo hello. So I have a new manifest file, and let's update our Docker file. And in this case, our Docker file is a little more complex in the fact that I'm going to actually use a Go container to build my main.go, output it to an echo file, and then this is the main part that's going to turn into my system extension from scratch. I'm going to copy that echo file to this echo path, or to this extension path. I'm going to copy the manifest file to the roots, and I'm going to copy a YAML file also to this etc container path. So if I look at my echo YAML file, this has the service config basically. If you think of like a systemd unit file, this is the YAML interpretation of that for a service, for a system extension service in Talos. So we're saying the name of the service, the entry point for what it's running, because you notice I don't have that in my Docker container. I don't say like what to run. I just say this is files. And then I have a restart of never. So I should get like one echo, and the binary is going to exit. It doesn't actually run a daemon. It doesn't repeat. It doesn't do anything. It just echo once and then shuts down. Talos doesn't care. It's going to say, all right, you're done. So we can build this whole thing, and we'll create another random image, container image that has these files in it, and we're going to push that up to this TTLSH. And this is, again, it's a little more complicated because I actually have to do a Go build here, but it's going to be basically the same thing. It's 3 files in a container image. One is my binary, one is my my manifest YAML to say how to actually use this, and then one is my service config on how to run it as a service. So we just named it. Now we can push it up to this random registry, and we're going to follow the same like imager sort of generation process, right? So we can still generate our installation media from that container image. And the only thing I'm changing here is what system extension I want to use. So everything else is going to be the same. Okay, our node is ready, and let's get our system extensions just to verify. We see I have this brand new Echo system extension. The difference here is I should also be able to look at Talos control services, and I should have an ext is like a system extension service that I have an Echo extension service, and I see it finished because again, it doesn't actually run a daemon. It's not running all the time, and it was told not to restart, so it finished. And let's look at the logs. Hello world, we're done. That was the entire thing of that binary doing any work on the system. It doesn't run again. It's not told to restart. It's only doing it one time. Let's go ahead and configure that with a service config. So I can look at this Echo env extension service config. That's the type. The only thing I'm doing here is I'm setting an environment variable to say Talos. And now I can apply this service config to the Talos API. It will automatically on disk look for the container environment or the container that's layered on, name Echo for a service or for extension, and then put this environment variable for that binary. So let's apply it. I have my control plane. I'm going to do a patch, do at Echo environment variable, sent that. So it sent it without a reboot. And I can see it rebooted. I got a Talos export. I still have my old log, but I also have this new Talos Echo. And so I just configured that binary by sending a config to it. And this is how you configure any service inside of Talos, any extension service. You would provide a service config and then add either files on disk, environment variables, whatever it is that that thing needs. In some cases for like Tailscale has a key to join your tailnets. iSCSI might have like endpoint credentials, something like that. And that applied the whole customization of building your own system extensions, either as files on a disk, as a service, or a configured service. These are all different ways that extensions allow you to do more things with Talos. There is one more system extension that is kind of unique, and I just want to talk about that one real fast because this video is already a little long, and if you really want to do this, we have some guides on how you can do that. We'll put a link in the show notes, but that's building kernel modules. Kernel modules are a little different than standard services or files on disk only because Talos requires the kernel modules to be signed by a signing key that Talos trusts. So when Talos is built, it's built with a ephemeral signing key, and then every kernel module is also built with that ephemeral signing key. So once Talos is built, you can't add any more kernel modules. You can't do anything to the system because it will not allow kernel modules to be loaded without being signed. And I believe Talos is the only Linux distro that forces that. There's no way to turn it off. There's no way around it. You have to sign your kernel modules with the same signing key or with at least a trusted signing key that the kernel allows. So if you want to go through and add drivers that require kernel modules, something like new GPU cards or whatever the case may be, you actually have to go through the process of building Talos first, building at least the kernel of Talos that creates the ephemeral signing key, and then creating a package that also gets created and kernel modules signed with that signing key so that those things can be trusted when they're loaded. Once you create the package, you go through, create a system extension, which uses that package files. And again, packages are just containers. Everything in Talos is a container. So we're just layering containers on containers to be able to get something all the way through a build process, all the way through a runtime requirement of signed kernel modules. So again, if you are interested in that, if there's hardware you're trying to add support for and it does require out of tree kernel modules, because again, if you're doing in tree kernel modules, if you need like things that are supported by Linux but just aren't enabled by Talos, you can do that a different way. We can add a link to that in the show notes too, because we have guides on how to do that. But kernel modules are like the final piece of this. Is a little more difficult. It's a little more involved to get a system extension that has been built with Talos all the way through to deploying that into an environment that you trust. That's the whole process for any type of system extension. Every single one of them is packaged as a container, it's layered as a file system on top of Talos, and then it's deployed, whether those are services, kernel modules, files on disk, whatever it is you're trying to do. You could package all of them up as system extensions and then deploy them to an already running system, or at the installation time, you can use those installer images to do it for you at boot and install time. We also have a video about overlays, which are a little different than system extensions. And so if you want to know about that, go watch the overlays video. That's for adding hardware support for small board computers, single board computers, things that don't have a UEFI or a BIOS to initialize hardware. It's a different sort of thing, but we don't need to address that here. They're just different than system extensions. It's a different time that you're customizing Talos. Thanks everyone for watching. If you have any questions, feel free to reach out in the community Slack, leave a comment below, or see us on GitHub. So thank you all, and we'll talk to you again soon.